Okay, so haven't done a video for a while. I've been working on a little development project, which is this one. It's basically just a multi-operator audio switch, and did using a PCB as a front panel, as that's the quickest way of getting it together. However, we've got out there we've got a 7700 Icom 7700 with no TX. So as the supply chain has dried up at the moment, deliveries are quite slow again. We're going to clear all this away and put the 7700 on, see if we can get that done and returned before Christmas. So stay tuned. So the the development project's moved over there, as you can see, all piled up on the soldering bench, and we've got the 7700 in place. Just gonna reach around the back, switch it on. You should see the standby light come up here. There she is. Press, the microprocessor will boot, and then it'll eventually go into receive mode. Well, there's a clue. It's in RTTY mode, and the RF power is up full, so that's 200 watts in a sort of digital mode, and that can really punish your PA. You're better off running them at half power in digital modes or less, my personal opinion. The old man has bought transistors or FETs just in case, the Icom ones, and they've come from Mauser Electronics. There you go, Mauser Electronics, which is a good source. It's better than buying fakes from China and not being able to get your money back. So I'm going to switch modes now, check that we're in the right aerial, and find a mic. I haven't got a mic with it. I'm going to have to go and hunt for a mic and then see how much power it actually does put out. So stay with us. Okay, so couldn't find a mic, so I'm going to use FM mode, which it's in, and push the transmit. So the meter is in power output at the moment, just under 10 watts, and the test set says 7.4 watts. I'm going to change it to the voltage. That looks right, and the standing current in the PA, which looks to be about 4 amps ish. So obviously that's not right, it needs to be a lot more than that. Well, the next step is take the lids off, get to the PA. It's not easy in this particular model, and get the PA out and have a look at the finals. It's quite likely the finals are gone. If it's been hammered in digital modes for a while, that certainly punishes those FETs. So I'll off camera, I'll take the lid off, get in there, and we'll see what we can find. So here we've got the lid off. Basically on the right is the antenna tuning unit. Big slab in the middle is the PA, a little bit warm. Then you've got the control logic on top, and the power supply with a single fan there, twin fans on the PA, and you'll see there's a ribbon cable runs all the way across the top of that and into the ATU, and you've got to sort of unstick all this. Ask anybody who repairs radios, and the thing they hit most is ribbon cables, because you never know when you unplug them if you're gonna actually damage it, or it's just not going to work when you plug it back in. But there's a fair amount of dust in here, as you can see. So the first thing will be to get the vacuum out and try and clean it up a bit, and then we'll start on taking the PA unit out which sadly means unravelling a lot of this these ribbon cables and sticky bits. We need to flip it over, take the lid off, and have a look what's been going on inside. Okay, so if you haven't done one of these before, the PA has screws down here on little pillars, one on either side, and also 4 black screws in the back, here, here, and here and here, and the PA is then loose to lift out. However, you've got to take the lid off the control board in order to get this loom out of the way, which prevents the PA from actually lifting out of the case. The PA sits on little studs at the back as well. Not sure I can get a view of those, but yeah, you've got to lift it at the back to get it out. So I'm just going to move this loom across, lift the PA out, and then we can start taking the lids off and see what's awry in the PA. When you're removing the PA, you need to release this cable form, which as you can see is very tight, and you can then disconnect the power supply and the control in order to flip the PA flat to work on it. Also the drive cable, which goes in the bottom, and the lead, this little control lead which plugs into there, actually comes out as you lift the PA from the bottom. The coax stays in, but the little control lead comes out, and that needs to be back in situ while you're setting the bias, which is one of the things that makes it difficult to actually set the bias on these, because you've got to fiddle about with it upside down. It's nearly always better to take the fan assembly off once you get to this stage. 2 screws here, 2 screws there. Take the fan assembly off and you're less cluttered. Now looking at this, there are 3 0.1 ohm resistors here which can burn out, but they look clean. I'm not testing them, but they look clean. Here you see the 2 finals and the driver. There's no sign of distress. All we're going to do now is to lift the gate tabs on each and put a test on them, see how they are working or not working, similarly with the driver. Normally you would do a drive level test, but it's a difficult thing to get at, so you're better diving into the PA straight away, as it is a fairly common failure with these rigs, especially when they're used in digital mode, as I said before, with full power. So I'll pull those apart, we'll get it flat, and we'll see what we can find. Okay, so we've got the PA out, move the radio set out of the way, and what I've done is unsolder the drain and gate tabs off each transistor so we can put a test across them. And this one is hooked up. Just going to use my little Atlas tester, press the button, and you see it says enhancement mode N channel MOSFET, which means that's okay. And I've actually done all the other 3, so that's okay, that's okay, that's okay, which possibly leaves this one, which is not able to test in circuit, and it's very difficult to unsolder it. There's a risk of damage to the board. So we're left now with a puzzle. It's either not enough drive, or it's a control situation, you know, the actual power level control, which does seem to work. It does vary the power of the 10 watts that's coming out. So I'm going to look at the manual to see what level of drive should be going in here. There's also a little transistor here that could have gone. So the RF goes into this amplifier, that amplifier, that amplifier, and those 2 finals. So yeah, and this board is particularly difficult to work on in situ because it's upside down. The leads are just too short to do anything with it. So yeah, we're going to have to ponder that one. I'll be back with you shortly. Okay, so having tested the main FETs and found they're okay, we're left with these 2. This is the small amplifier straight from the exciter, and that feeds the the transistor that's very difficult to get off, and we don't want to risk damaging it, so we've had to think of a way how we can get around this testing. So what I'm going to do is we zip across here. Let me get it in on the screen. So we're going to feed 15 volts in at this point. Let me just move it across a bit more. So we're going to feed 15 volts in at this point, where you can see it comes from the multi-way plug, and that 15 volt line here feeds both of those FETs, so we're able to test them in situ. But also it feeds this 7A LO8 regulator, and this voltage here, the 8 volts, is keyed through this transistor and provides bias to the 3 stages of output. And it could be that there's no bias being supplied, in which case the FETs wouldn't operate. So by applying 15 volts here, we're able to make sure this is firing, giving 8 volts out. We can actually ground this resistor to ground, which will turn that transistor on, and that should put bias into the PA devices, although there's no collector, or should I say there's no source voltage on, because that's 48 volts and we don't have that. But it'll allow us to also excite those 2 stages with from the signal generator, so we can put an RF drive in here, see if that's got amplification, and see if that's got amplification, and that'll be a pretty good test of those in situ. So that's what we're going to do next. I'm going to set that up, and we'll see how that works out. Okay, so I've got my 15 volts going in, 15.046 into the 15 volt line, which feeds the very small FET here, and this one also feeds the 8 volt regulator, which is this device, and there is 8 volts coming out of that. I've tested it. So what I've done is I'm feeding 14.1 megahertz into the exciter input, and I'm going on to the gate of that, and looking at the spectrum analyzer, that's the input going into that FET. There is an attenuator on the between the connector and the device, so that's reading neg 24 dBm into the gate of that device. I'm now going on to the output, and as you can hear, it doesn't like that. Let me do a measurement reset. There we go. Try again. That's the RF input to the small amplifier, and that's the output. I can't see any output whatsoever. So I'll just do a quick voltage check, and I'll come back to you. Okay, done a voltage check, and there's volts on the device. So again, we'll try using a DC blocking. That's the input to the device, as you can see, neg 27 approximately, and then we're going to go on the output of the device, which is neg 54. So there's no gain in that stage whatsoever, so I think that's our culprit. I'll take it out and measure it, but I don't think I have one in stock, which is a problem before Christmas, but we'll see how that goes. Okay, well, I actually do have them in stock, so I must have had this problem before. Here's the pad. I've taken the old transistor out. When I put the soldering iron in, it actually broke into 2, so maybe that's a good sort of omen that it was gone. Here's the replacement device. You can see how small they are compared to my finger. So we're now going to solder that in here, and then add the 15 volts in the drive and see if there's any amplification there. And if there is, I think we're fairly safe to put all this back together, which takes a while. Okay, so I've changed this transistor and it now has some gain. This one, however, has no gain, and that's the one that's going to be very difficult to get off. Plus I haven't got one in stock, but I'm going to have to take it off one way or another. But I thought I'd set the camera up on the spectrum analyzer, then you can see the difference. First of all, we're going to measure the input here on the input to that gate, and then the output of that FET here, which should be the input to this FET here. Then we're going to go to that one there, and what you'll find is between here and there is a loss of quite a few dBs, which means that this is not functioning. Now, to get that to work, I have to short out the little control transistor, which turns on the bias so that that and that have bias. But I will set the camera up on the spectrum analyzer, and then I'll tell you what I'm measuring as I do it, so you'd have an idea of gains and losses, etc. Okay, so using a capacitive probe, I'm now going to look at the input to the first FET amplifier, which is looking like neg 28 dBm. These levels are not accurate because it's just a simple probe, and the output of that amplifier, I can get onto the pin with the bias turned on. Turn the bias on, is neg 11, so there's definitely gain in that stage. So going on to the larger transistor, which is awkward, neg 12, that's the drive at the input, and then going to its output, as you can see we're down to neg 31, so there's definitely no gain in that stage, and it looks like I've got to figure out a way of getting that out without damaging the PCB, which will be interesting. So like the previous transistor, it was easier than I thought. Just touched it with a soldering iron and the top came off, which left the legs fairly easy to desolder. And here are the remnants of that transistor. So we're going to have to have a look online. The local Icom dealer may possibly have one, not sure, but that's our best bet for a quick solution. Other than that, we've got to go off to you know, various wholesalers, but definitely not Chinese. Well, Mauser have them in stock, be about $40 including shipping. I'm not sure about the delay though. I was hoping to get this off the bench so I can continue with my development. So what I'll do is I'll ring the local Icom outlet on Monday just to see if they have stock, which would be great. If not, then I'll have to see what delivery Mauser have. I'll have to do something else on the project. Okay, I'll get back to you. There will be a part 2 to this video, so look out for part 2. See if we actually get this thing up and running. Cheers for now. This is Joe, ZL1PMY.